Everybody, this is Dr. Maples. Today we're going to do some quick analysis in R. What I want to do is walk you through the assignment that you'll be working on in my class and also just generally show you some of the basic features of R. Now for this assignment, I've pulled up a particular data set that is available on our Blackboard page, and I can send that to you if you need it. It is a data set of Kentucky counties, and it includes some health demographics and more variables in there that we're going to analyze. And for this particular data set, recall that you're going to be doing a descriptive statistics table, and you're also going to be doing some t-tests that will test out some hypotheses. So I'm going to walk through those steps. Now, just so you remember, if you need to open up this file for the first time, you simply go up here to the upper left-hand corner and click on File and open the file from there. So it's just like you would a Word document or any other Office Suite thing. Once you got your data set open, it'll look probably something like this in RStudio. You'll have your variables up here that you can see as well as over here, and it'll give you lots of information about those. Now remember, this one up here is kind of like an Excel file, so let's pretend that you wanted to sort things out. You can click on these little arrows up here and actually sort out your cases. Or if you want to put your IDs or your cases back into a particular order for IDs, you can do that, and all these other things. Now, this particular data set is counties, so it also has the names of each county. Keep that in mind when you start talking about the analysis. We're not talking about individual persons. Rather, we're talking about counties in the state of Kentucky, of which there are 120. So let's get started. So the first thing that we're going to do is start on our descriptive statistics table. That's table 1 in the assignment. And for that, you have to do min, max, and mean. So your minimum value, your maximum value, and your average value. I'm going to show you how to do those. Now let's start with minimum. First thing that we do is we simply type in the command min. And next thing that we're going to do is put in parentheses what we exactly are wanting to get the min of. Now with R, it uses a really cool technique where you name the data set and then the variable. And that makes it so that you could actually have multiple things happening inside your RStudio environment, but we tell it specifically what variable that we're wanting to look at. So in this case, we happen to know, because it's right here, that our final data set is the name of our data set. So we type it in and watch what happens. If you type in a few letters, it'll actually pop up. So I'm going to click on it. And now what I'm going to do is put in a $sign. And that $sign tells the computer in RStudio that I'm about to tell it a particular variable. In fact, you'll see it just came up with a whole list of different variables that I might put in. And for my particular analysis, I want to do physically unhealthy days. So there we go. I've got the min, and then I've got the name of my data set with the $sign and the name of the variable all in parentheses there. And when I hit enter, I'll get the results. In fact, the minimum score for physically unhealthy days for counties in the state of Kentucky was 2. So there's a county somewhere that has, on average, 2 unhealthy days. In fact, let's look at that. If we go back up here, we can move over and find that physically unhealthy days, and we can actually find out more about that. Clicked on it right there. It looks like we have one county with 2 unhealthy days. Looks like that's Clark County, Kentucky. So good job. Health is going pretty well for Clark County, Kentucky. They had on average for the residents 2 unhealthy days per year. Now what if I want to do the max? Now the maximum is the maximum value, and that's just simply max. But what if I want to do it an easier way? Can I show you an easier way? Watch this. If you hit up key on your direction pad, it'll put up what you just typed in. And you can go in and just do this. And you hit enter, and there's your result, 11.4. And sure enough, if we were to go back into this little data set up here, we could type this in so that the maximum one is at the top now. And so 11.4, there that county is. Let's see what that county is called. That county is called, Bell County, Kentucky. Looks like actually most of the Worse off counties physically health-wise are in eastern Kentucky. There's Menifee from the red, Magoffin, Pike, Metcalfe, Rockcastle, not. So several ones, not. I don't remember that one's in eastern Kentucky. But we've got several of these worse physical health day ones, and there they are. Now let's go back to our other screen for a second. So we have our min and we have our max. If we want to do the mean, it's the same thing. We just type in the word mean, then we give it the data set and the variable name. And if I just hit the up key, it puts up my old stuff that I just said. I can type in MEAN, and look at that. The mean was on average 6 unhealthy days across all the counties in the state of Kentucky. Now, I want to show you a little trick. This is your bonus for getting to watch this video in addition to the course lecture videos that I've also got on YouTube. We can actually type in something called summary, and we can type in the name of our data set. Are you ready for this? You have to do descriptive statistics on multiple variables in this assignment. So when you type in the word summary and hit enter with the dataset name there, it'll actually summarize all the variables for you. So you could literally go through and build your table step by step just using this one command if you want. Because look, it's got the min, the max, the min, the max, and the mean. It's also got quarterlies in there, or quartiles rather, in there if you want them. But we don't need that for our assignment. And look, there it is. Physically unhealthy days, minimum of 2, maximum of 11, and a mean of 6. Likewise, I also did in my assignment mentally unhealthy days, so that's listed there, and then also did percent of insufficient sleep, which is down here. Now, I do want to point out one thing really quickly, because as part of this assignment, you're going to be working with dichotomous dummy variables, which are measured at 0 and 1. 0 means the absence of the trait, 1 means the presence of the trait. And in this case, App County is one of those dichotomous dummy variables that I have in here. You'll probably be creating your own, though, in your work. But for me, I want to talk about what this mean implies. So you can see the App County's min was 0, which that makes sense, and a max was 1, also makes sense because 1 means it's an Appalachian county, 0 means it's not. But it has a mean of 0.45. So what does that imply? Well, we can interpret that as saying 45% of the counties in this data set qualifies having the trait of 1, and 1 happens to mean that you're an Appalachian county. So that's 45% of the counties in there are considered Appalachian counties. Just wanted to point that out really quickly so you were aware of that. Now let's do some other commands. Now, the next thing you're going to be doing is doing a t-test. Now, for me, as an example assignment, I set up a t-test that said something to the effect of being in an Appalachian county will correlate with having higher numbers of physical unhealthy days compared to non-Appalachian counties. So that means basically if you were someone who's living in, say, a county that's in Appalachia, like Estill, for example, then on average, you're probably going to have more physically unhealthy days than someone living in a county in western Kentucky that's not in Appalachia. To do that is really simple. We can just do t.test. Now, this is a basic independent samples t-test. What we're going to do in parentheses is we're going to put both of our variables. Now, the first variable we're going to put is our dependent variable. This is the variable where we expect to see change based on changing this category of Appalachian or non-Appalachian. So I'm going to type in my data set name. Oh, there it is. I'm going to put a $sign, and it says, oh, I know what you want to do. And I'm going to scroll down, and sure enough, physically unhealthy days right there. But instead of putting like a comma or a space or another $sign, I'm now going to put in a tilde. And this little symbol tells the computer what I want you to do is see how this variable, final dataset $sign physical unhealthy days, might vary by whatever comes next. Whatever is going to come next happens to be Appalachian County, which I happen to know is at the very bottom of the list. Now, what it's going to do is give me an output on this that tells me the means for both of these. It's going to give me some information on the t-test score, the degrees of freedom, and it's also going to give me a p-value. We'll come back to that p-value in just a minute because I want to explain how we use that, and then I want to point out a little problem that you may be experiencing with it. So when we hit enter, we get that output. It runs this Welch two-sample test, and what we end up with is that it shows that the mean for group 0 here is about 5 days, and the mean for group 1 is about 7 days. So to summarize that, that means that living in an Appalachian county, they see an average of about 7 physically unhealthy days per year. And for the mean for non-Appalachian counties, it's about 5. Our T-score here, we got negative 6.6. The degrees of freedom, 104. We simply report these in the table. There's also a p-value. Now, you may actually have a p-value that isn't listed that way. You may actually end up with a very strange p-value that's in scientific notation. Never fear, there's actually an easy fix for that. That's something that we can fix. In fact, all you have to do is put in this little code right down here at the bottom. It says options, and then parentheses, it's SciPen equals 999. And when you do that, it's actually going to get rid of the scientific notation on the p-value. Now, if your p-value is reporting just like mine is, you'll be just fine. But otherwise, that'll fix it from then on. So that's it. We've done the basics of describing a variable. I've showed you also how to use summary to describe all the variables in the data set. And I've also now shown you how to do this simple t-test to do for your hypotheses testing. All right, that's all for today. If you have questions, reach out to me. I'm happy to help. Otherwise, I'll see you next time. Take care.